Hello, welcome to ANS Solver. This is the fourth question of the paper. So as you can see, there are a number of insects with a population T weeks. Okay, after the start of the observations, denoted by N. Okay, the population is decreasing. Okay, at a rate proportional to this. The variables N and T are treated as continuous, and it is given that okay. So now we need to show that N and T satisfy this differential equation. So first thing I'll write is that my dn by dt is directly proportional to n e raised to minus 0.02t. Agreed? So now when I change this to equal to, when I change the sign to equal to, a constant comes into play and I can write something like this. Okay, so now I know I have this piece of information with me. So in dn by dt, I can put minus 10 equals to k into 1000 into e raised to minus 0.02 into 0. So I can write this as minus 10 equals to 1000 k, and I know this is basically e raised to 0, which is 1. So I can basically write k as minus 10 over 1000, okay, where I get my k basically as minus 0.01. So finally I can say dn by dt equals to minus 0.01, okay, into e raised to minus 0.02 t and n. Okay, yes, so this is the second part of the question. So now I need to solve the differential equation and find the value of t when n is equal to 800. So what do? First step is the variable separable form, which basically means keeping the n together and the t together. Okay, so I can simply write this as 1 over n dn equals to minus 0.01 e raised to minus 0.02 t dt. Now I simply integrate both sides, so I can split this like this. The integration of 1 over n is simple ln n, okay, and the integration of this is as it is. First I'll write minus 0.01 into e raised to minus 0.02 t over the coefficient of t, which is minus 0.02, plus c, because there are no limits, indefinite integration. So I can cancel this, so I get 1 over 2 e raised to minus 0.02 t plus c. So I can simply write this as ln n equals to half e raised to minus 0.02 t plus c. Now I know my t is equal to 0 and n is equal to 1000. So I can simply say t equals to 0 and n equals to 1000. So I can write this as ln 1000 equals to half into e raised to minus 0.02 into 0 plus c. So I basically get 1000, ln 1000 equals to half into, I know this is simply 1, plus c. So I get my c basically as ln 1000 minus half. Okay, so now I can simply write the final equation as ln n equals to half e raised to minus 0.02 t plus ln 1000 minus half. Okay, so now I need the value for t when my n is equal to 800. So what I basically need is, I can say let n be 800. Okay, so I can write this as ln 800. Now I can take this full thing to the other side to get minus ln 1000 minus half equals to half e raised to minus 0. This will be plus half, minus 0.02t. Now I can simply solve this on the calc. So ln 800 minus ln 1000 plus half. So the value I get is simply 0.02768. It is equal to half into e raised to minus 0.02t. So I can simply write this as, I can multiply 2 with this. Okay. So the value I get is simply e raised to minus 0.02t equals to 0.5537. So now I can write this as ln e raised to minus 0.02t equals to ln 0.5537. Now I know a log property which states that log of a raised to b can be written as b log a. So using this log property, I can write this as minus 0.02t with ln e equals to ln 0.5537. I know ln e is simply 1. So I can write this as t equals to ln 5537 over minus 0.02. So I get my t basically as, if I solve this on the calc, I get my answer as 29.6 to 3 significant figures for t. Okay? Yes, so this is the third part of the question. So we need to state what happens to the value of n as t becomes large. But for that, we need to rearrange this equation a little bit. So we got this equation basically from part 2. Okay, so how do we rearrange this? I can write this as ln n plus half minus ln 1000 is equal to half e raised to minus 0.02t. Now I need to know a log property that states that log a raised to b can be written as b log a and vice versa. That means I can write half as ln n plus ln e raised to half. Obviously, because it can be written as half into ln e, and I know ln e is 1, minus ln 1000 equals to half e raised to minus 0.02t. Now, plus means multiplication, minus means division. So I can write this as ln n into e raised to half over 1000. Agreed? It is equal to 0.5, e raised to minus 0.02t. Now another log property I know is log b with the base a equals to c can be written as b equals to a raised to c. So I can simply write this as, I know the base of ln is e. So n e raised to half over 1000 equals to e raised to 0.5 into e raised to minus 0.02t. Okay, this is what I can write. So my n is basically e raised to 0.5 into e raised to minus 0.02t, okay, with 1000 here over e raised to half. Now, when t becomes large, I know when t tends to infinity, let's say if it becomes large, tends to infinity, I know this will become 1000 with e raised to 0.5 into 0, correct? Because when it tends to infinity, over e raised to half. So now I can simply write this as n equals to 1000, okay? This is simply, I'll get this as 1000 over e raised to half. This is basically the final answer of the question.